We are Thin Film Solutions, and our product, the self-healing circuit, was developed by a team comprised of Rob Landry, who is in charge of business plan development, Ryan Cato, who is in charge of cost analysis, Joseph Wang, who is the chief executive organizer, Jeffrey Filak, who is in charge of product animation, and Varun Varanasi, who is the lead researcher. As a company, our goal is to leverage innovation in order to combat microcracks and flexible circuit deterioration within aerospace technologies, as these circuits are subject to pyroshock and other means of harmful deterioration. Circuits perform functions communication to computing and control. Pyrotechnic shock, otherwise known as pyroshock, is the long-lasting, extremely high frequency and high amplitude structural shock waves introduced by explosions near structures. This can be caused in rocket stage separation, missile payload deployment, and pilot ejection, and this shock causes 20% of circuit failure. Microcracks are small fractures that form in flexible electronics over time due to pyroshock. These cracks eventually propagate through the device, reducing conductivity and damaging the device. Phobos Grunt was an example of a $64 million project which failed due to circuit failure. Our product prevents such catastrophic events from occurring, and the current market has no self-healing circuits to meet this need. Our solution is to create a conductive, self-healing liquid metal thin film to fill in these microcracks, restore conductivity, and prevent further damage. The first step in this process is particle solution synthesis. In this step, we produce a liquid metal nanoparticle solution with dissolved magnesium sulfate. The role of the magnesium sulfate is to add a partial positive charge to the nanoparticles. As you can see in the animation, they're binding to them. This will be crucial in allowing the particles to be more responsive to electrical fields, a key feature in our next step, electrophoretic deposition. The solution which we have just synthesized is contained within a glass container, as well as 2 copper plates. When an electric potential is applied, the newly positively charged ions will be attracted towards the negative end, resulting in the appropriate treatment of the liquid metal thin film onto our desired circuit. Once deposited, we have formed a self-healing circuit. The self-healing property arises from the ability of the liquid metal to produce a solid oxide layer. This layer adds mechanical stability, allowing it to maintain its structure, and because of the immediate formation, if the layer is ever disturbed, it will immediately self-heal. Through our research at NC State University, we have created an industrial scalable prototype, depicted above. We seek to penetrate the aerospace industry for application on rovers, rockets, and satellites, then expand our market to include flexible electronic companies in the future. We would like to thank the following people and institutions for their support throughout the development of our product.